what we want to do here is, given this function here, we want to find the equation of the line tangent to this curve at this point. Now notice first, this point is actually on this curve. If you put negative 2 in for x, you're going to get negative 2 squared, which is 4. 4 minus 16 is negative 12. And then put negative 2 in here, you get negative 2. So negative 12 over negative 2 is negative 6. So when x is negative 2, y is negative 6. So we want the equation to the tangent line. Now, just asking us for the equation of a line. Now, maybe you remember these. Let's see. I'm going to write down the templates we have for equations of lines. So, you have this one here, y equals mx plus b, the slope-intercept form. And I don't think we're going to be able to use this because we don't really have b. b is the y-intercept. This is not the y-intercept, right? We're over 2 down 6. So we're probably not going to, this is not going to work too well for us. So let's not use that one. The other one we have is y minus y1 equals m times the quantity x minus x1. This is the point slope form because we're given a point, x1, y1, which we have right here, and the slope. So we need the slope. But we know how to get the slope, right? Because the slope of a curve is just its derivative at this particular point. So let's get the derivative of this function right here. So it's a quotient. So y prime is going to be, I like to write the template, bottom times the derivative of the top minus the top times the derivative of the bottom, all over the bottom squared. Let's see where it takes us. So y prime is the bottom, which is the quantity x plus 4, times the derivative of the top, which is 2x, minus the top, which is the quantity x squared minus 16, times the derivative of the bottom, and the derivative of the bottom here is just 1. All right, all over the bottom squared. So it's the bottom, that x plus 4 is going to get squared. So a little bit of algebra here. Y prime is equal to, let's multiply through, right, distributive property. So we'll get 2x times x is 2x squared plus, then right in here we'll get 8x. So 8x. And then over here it's going to really be, think of negative 1 times all this. So let's just multiply that negative 1 through. Negative x squared plus 16 all over the x plus 4 squared. And now, where are we? Well, 2x squared minus x squared is an x squared, and then we'll have 8x and the 16. So let's write that. So I'll do it right up here in the right top. Y prime is x squared, and then we've got a plus 8x, and then a plus 16 all over that bottom, x plus 4 squared, and we have a rational expression here. We always try to reduce it, and to reduce one of these we factor and cancel. So let's factor this top, and maybe you see it right now. Y prime is, okay, I'm going to factor it like this. X and x, the factors of 16, that'll add up to 8. How about 4? So we'll get plus 4 over x plus 4 squared. Well, this x plus 4 will cancel with one of those. This one will cancel with one of those. So now it doesn't just go blank. Y prime is 1. So what we've got now is that the derivative is equal to 1. And the derivative, this is equal to the slope. So now we have this. We're going to use y minus y1 equals m times x minus x1 with, all right, x1 will be our first x value that we see, which is, now take it back up to the point, the first x and the only x value we see is negative 2. So x1 is negative 2. y1, okay, the first y value that we see here is going to be negative 6. So y1 is negative 6, and m we just found to be 1. So let's substitute those numbers in to our template. So we will have y minus y1, y minus negative 6 equals m, which is 1. times x minus x1, which is negative 2. All right, this will give us y plus 6 equals 1 times x plus 2. That's just x plus 2, so we'll get y plus 6 equals x plus 2. Subtract that 6 from both sides, and we will get y equals x. Now, 2 minus 6 is negative 4, so if we haven't done anything wrong, we're going to claim that that is the slope, that is the equation of the line tangent to this curve up here at that particular point.